All right, gang. Let's keep going. All right. Hey, so the quiz we're going to have today, here is something that will come up. Can someone tell me why this one's not a function? Say it loud. So this x right here, this would be x equals 3. It goes to 2 y values. So this is sort of like you're plugging the bread into the toaster and you're getting the toast and the spaghetti out. So remember that. I wouldn't be surprised if something very similar to that were to come up on your quiz today. Nope, I would not be surprised. I would not be surprised if that were the first question on today's quiz. Is something not unlike this, where you're going to look at it and say, no, this is not a function because this x value is being sent to 2 y values.
No way. You never do that.
You don't think so? No, you don't know me at all. All right, now here's what I really want you to get out of this. We know that the inverse function failed this vertical line test, right? It would be nice if you could look at the original function and immediately tell from the original function that the inverse is going to fail the vertical line test. So Sadie sees something.
Looks like both on the same line.
Yeah, right here. So we call this not a vertical line test, but a... Yes, so this fails the horizontal line test. Okay, and I should be more specific. What is this function? G. G of x fails the horizontal line test, and what that tells us, this little arrow is an imply symbol. That implies that G does not have an inverse. Yes, Sarah. What are the ovals for? Something else I was going to do, but now I'm not going to do it. So here's what they're for. There, done.
Oh, I see. That makes
I'm glad you asked. Jack, what's up, man?
Okay, so the horizontal line test for like the regular function, does that like let you know that it's both not a function and it doesn't have an inverse?
No. Good question. If you want to know whether this is a function, what you're going to do is do a vertical line test. So passes a vertical line test, that means that G is a function. Fails a horizontal line test means that it doesn't have an inverse. Okay? Yeah, good question. All right, hey, let's go to the next page. The next page has some true-false questions on it, and we'll do a few of these together. So you can put your pencil right here on number 1. It says a of x has an inverse function. Is that a true statement or a false statement? So you want to look and say, does this pass a horizontal line test? Yeah, see, it fails right there. Fail. Okay. So does it have an inverse? No, it doesn't. So that's a false statement. No inverse for this guy. Okay, let's do the next two at the same time. 2 and 3. They both say this has an inverse. One of those statements is true, one of those is false. See which one you can figure out is, I have a vote for true and then false. Do I have a second for that? I have a second for that. Can someone explain to me why the second one is going to be false? There are 2 10s, yeah. So if you look right there, 2 of the same output means that this one's going to be false. It would fail the horizontal line test. This one's going to be true. Okay. Do one more with you. Number 4. What kind of function is this? Here's something that'll come up on your quiz today.
Isn't that like cube root?
This is the cube root. This is y is equal to the cube root of x. Wouldn't be surprised if that shows up either. Nope, still not surprised. So look at this guy. Does this guy pass a horizontal line test? Okay, so does he have an inverse? Yes. Yes, he does. All right, I am going to be quiet for about 2 minutes. I would like you to grab your partner or neighbor or someone right next to you, or just work by yourself and see if you can do those 5 true false right there. 5, 6, 7, 8, and 9. Hey, Jake.
On number 5, it says, if f of x is a function, then so if f.
Oh,
Is that supposed to be so?
then
is?
so is. Yes, yeah, you got it. Should say then so is. Okay, I'm going to give you guys just a little direction. 2 of them are true. You think you know which 2 are true?
Yeah.
Okay, Sarah, what are you thinking? Number 7 is true. And number 9 is true. You've got it. What do you guys want to talk about from these? False, false. Number 5? Okay, and number 8. Okay, so 5 says if f is a function, then so is its inverse. Here's an example of one where you have a function. This is a function because it passes the vertical line test, but it doesn't have an inverse function because it fails the horizontal line test. So that's why this one's false. The other one we want to talk about was 8. Remember how when you have an x and y, the inverse switches the x and y? So that's why right here I said if f sends 3 to 7, then f inverse would send 7 to 3. So you want to switch from there to there. See how these are not switched? So that one's not true, that's false. Right here, this one's true because we switched them. Sort of like if the original function goes through the point 3.7, then we know the inverse is going to go through the point 7.3. Are we good? Are we good? Are we good? We're good. All right. Now things are going to get a little goofy. Let's go to the next page. Okay, so I'm going to tell you about some of my favorite function. Jake. Here's Jake of x. I'm going to tell you a bunch of stuff about Jake of x, and then down here, it's going to be your job to tell me about inverse Jake, evil Jake, bizarro Jake. So let's start up here. We know Jake's domain, we know Jake's range. So if we know Jake's domain and we know Jake's range, what do we know is going to happen with those for inverse Jake down here?
They're going to swap.
Yeah, we're going to switch them. So that's the easy one. You can just take the domain and the range up top, bring them down here, and switch them. So our domain is going to become this, and our range is going to become this. Y'all good so far? Okay, this is where it gets a little bit goofy. I want you to write the rest of these statements so that they all look kind of like this right here. So see how that says Jake of -2 is 7? Could you write a similar statement for this? The graph of J of x passes through the point 5, 8. Yeah, Jake of 5 goes to 8. Okay, that one's not so bad. Ooh, this one's a little more challenging. Jake has an x-intercept when x is equal to 8. So that would mean that Jake goes through this point right here. Isn't that on the x-axis? Oh, okay. So, that's actually not so bad. If we know that, that means Jake of 8 is equal to 0. And then one more. The y-intercept of Jake occurs at y equals 5. Okay, so the y-axis is right here. And that point would be 0, 5. Does that look good to you guys? All right, so Jake of 0 is 5. So we've got these 4 statements right here, right? Okay, I want you to take those and turn those into inverse statements. So I'll do the first one. Inverse Jake would take 7 and send it to -2. What did I do with the x and y? Switched them. Okay? Now you guys know what to do for the rest of them. Inverse Jake would send 8 to 5. Inverse Jake would send 0 to 8. And inverse Jake would send 5 to 0. Okay, so now we wrote these statements and then we rewrote them using the inverse. I'm going to be quiet for about a minute. I want you to get together with your partner or do it on your own and fill in this information right here.
Wait, what do you mean by negative 0 with negative j?
What was that?
What does it mean by negative 0 with negative j down below?
Remember that a 0 is a number that you plug in and you get 0 out. Yep, good question. All right, check your work. Inverse J of 5 is 0. Inverse Jake of 0 is 8. Inverse Jake of 7 is -2. There's 2 left here. One of them can't be determined. And it's this guy right here. Yeah, see how we don't have a -2 over here? So this one's going to be cannot be determined. And then the last one says the 0. The 0 is the number you plug in and you get 0 out. So it's going to be x is equal to 5. Yep. Okay, we good up to there? All right. Flip the page then. This is the last piece of the puzzle. I'm going to give you a function, and then you're going to give me the inverse function. So we're like writing equations now. And it's really, really good if you can picture what the graph looks like. Ooh, so let's start with this guy right here, x squared. What kind of shape does that make? Yeah, that's going to be a parabola. So it's going to look like, ooh, and that +5. Here's something that'll come up on today's quiz. What is that +5 going to do? So the graph would look something like this. It's a parabola. It's been shifted up to 0, 5. Does that pass a horizontal line test? Oh my goodness. The first one was so easy, folks. You know what our answer is? None. No inverse because it fails that horizontal line test. Beautiful. Let's go to the second one. Second one says that Gary is equal to x squared plus 5, but only when x is greater than 0. So if it's only when x is greater than 0, we're not going to get this whole graph. What part are we going to get? The left side or the right side? Yeah, we're going to get the right side because the right side is where x is greater than 0. So this one's going to look something like this. Now, does that pass a horizontal line test?
Yes.
It sure does. So this time, you guys can come up with an inverse function. And here's how you do it. It's a very simple dance to do. First, we know that g of x means the same thing as y. So I'm going to rewrite this as y is equal to x squared plus 5. And then the second thing we're going to say is, what have we been practicing all along? When you do the inverse function, what do you do with x and y?
Swap.
You swap them. So step number 1 here is going to be to swap x and y. You're going to say x is equal to y squared plus 5. So see, I put the x here where y was. I put the y here where x was. There's our equation. Now, we write functions as y equals, so you can probably guess what your next step is going to be. See that y right there? You got to solve for that. So step 1, swap x and y. Step 2, solve for y. So I'm going to throw this out to the group. We want to get y by itself. What's the first thing we need to do here? Okay, so let's take away 5. Let's take away 5. So we're left with x minus 5 is equal to y squared. Is y by itself? It's close. It's still got that squared there. How are we going to get rid of that squared? You're going to square root both sides. No, now I know that usually when we square root, you get a plus or minus. But here, because it's a function, you're just going to get the plus. So you're going to get square root of x minus 5 is equal to y. And then here's how I want you to write your answer. The original function was Gary, so this is going to be Gary inverse of x is equal to the square root of x minus 5. Oh, okay, so now we know that when you get a squared, the inverse is going to be a square root. Take a look at the next one. Folks, what kind of function is this? Yeah, it's linear. You got it. Anyone want to guess what the inverse of a linear function is going to be before we find it? Quadratic gave us square root. Negative, okay, it's a possibility. Here, well, let's go. Let's see. I'm going to change that to y. And then step 1, I'm going to switch the x's and the y's. Okay, so we get something that looks like this. All right, I'm going to call on you guys a little bit as we go through this one. Isaiah, I would love if you would get us started. What do we need to do first to get that y by itself?
Subtract 5.
I like that idea. Now, you could distribute the 1/3, but did you see that if you do that, you're going to get a bunch of fractions? Yeah, exactly. So I love that idea. Let's subtract 5 from both sides. So minus 5, we get x take away 5 is equal to 1/3 of y minus 2. Okay, we're killing it. Where do we want to go next? Jack, you got a thought?
Would you divide both sides by y minus 2?
You could. You could do that, but then you're going to have y stuck in the denominator. So it might be better to think about that right there. What can we do with that? Yep, let's do that. Now I'm going to multiply this side by 3. When I do that to the other side right here, you have to multiply the whole thing by 3. So now we're at 3 times the quantity x minus 5 is equal to y minus 2. We're almost there. Decille, finish it up for us. What do we need to do next?
Add two.
Yeah. So when I add 2, we're going to get, what, 3 times x minus 5 plus 2 is equal to y. So we started with a line, and the inverse is another line. Yep. The inverse of a line will always be a line. You're going to write your answer this way. Inverse h is 3 times x minus 5 plus 2. What are you guys wondering about? David? You could simplify it. What would you do to simplify it?
Could you distribute the green? Just like carry on through that?
You could. If you want to, you're welcome to. You're also welcome to leave it this way. Either of those are fine. All right, we're moving. We are grooving. We're taking a look at the next one. Ooh, this is a cube root. Yeah, Sarah, you got a question.
Could you read the last one aloud again?
Are you having a hard time seeing it from where you are?
Yeah.
Okay, hang on. I got you.
Oh, okay.
Can I go any closer than that? Is that close enough?
Yes, thank you.
All right. Boom, 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 boom. Back it up, back it up, back it up, back it up. All right, we are moving. We are grooving. We are checking out this guy right here, everybody. Ooh, cube root function. Now this was squared. What does cube root function look like? Yeah, it's this guy, right? So you know that this one's gonna do that kind of shape. Does that have an inverse? Yes, it does. It passes that test. Okay, so let's do it. Maddie, get us started. What's the first thing we want to do here? Okay, so I'm going to call this y. And then step 1, we'll call that x is equal to, over here the 5 is multiplying the cube root of y plus 2 plus 7. I like it. Good stuff. Andre, pick it up from there. Let's do some algebra. Okay, so what would that give us?
X minus 7 equals 5 times the cube root of y minus 2.
Mm-hmm. I like it. David, pick it up from there. What would we need to do next? This one's a little trickier. I'm actually going to ask you a question. Why is it that we can't cube this yet?
Because the 5 is there.
Okay, so we got to deal with that 5. What do you want to do with that 5? It's multiplying?
Could you divide that by?
Mm-hmm. Yep, that's exactly what you're going to do. Now, when you divide by 5, you're going to get a fraction over here, and you're going to be like, ugh, ew. Just leave it that way. It's okay. So now we've got x minus 7 is divided by 5, and that's going to give us the cube root of y plus 2. All right. Yeah, I like that idea. Now that we've got that cube root by itself right there, we can cube both sides. So we're getting x minus 7 over 5 cubed is equal to y plus 2. Subtract 2 and you're all done. Okay, so minus 2 here. Sarah, I'll try to write this nice and big. M inverse of x would be equal to cubic minus 2. All right, what kind of questions do we have, gang? Decille.
So like do not answer. Oh, we're not like never gonna have the line in it.
Are we not going to have the y in it? I kind of skipped a step. Right here, it would say x minus 7 over 5 cubed minus 2 is equal to y. and then I changed the y to m inverse. All right, we hanging in there? We with it so far? Because I saved the best for last. And by that I mean the last problem we're going to do today is this one, and it's the hard one.
Oh, I love this one. Fractions.
Boom, 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 boom. Okay, now the fraction is one thing, but there's actually a bigger problem on this one. It has something going on besides the fraction that none of the other problems had. Yeah. Okay. And look what happens. Because there's two x's, do this one in blue. When we switch, we're going to get x is equal to, on the other side, 5y minus 1 over 3y plus 8. So now there's two y's. And that's a problem, because what do we need to do? We need to get y by itself. Let's do it. First thing, we don't like fractions. Do you like fractions? Faisal, you like fractions? No. Sadie, you like fractions? Okay, let's get rid of the fraction. So right here, see how you've got a proportion? X over 1 is equal to this over this. When you got a proportion, what can you do? So once you've switched, you're going to cross multiply. That's going to give you x times the quantity 3y plus 8 is equal to 1 times the quantity 7y minus 1. And this is good because the fraction's gone, right? Like, we like that. We want the fraction out of the way. But it's bad because we've still got two y's, and one of them is trapped inside the parentheses. So let's get it out of those parentheses. We're going to take that x, and we're going to distribute it to these two terms. So this would be x times 3 times y. I'm going to write that this way. Doesn't really matter what order you write them in. Not that much, but we usually put the number first. Plus x times 8 would be 8x. And this is really, really good because the parentheses are gone. But it's bad because we've still got two y's. And if you want to get that down to one y, which we need because we're solving for it, why don't we get those y's together? And by get them together, I mean, let's get them on the same side of the equation. Now, it doesn't matter what side you put them on. I am going to say, let's put the y's over here on the left side, which means, see that 5y right there? We need to subtract that here and then subtract that here. Cancel out. Now look at that 8x. That 8x is just kind of hanging around. It's a real third wheel. You got a date to the homecoming dance. You don't want your little brother coming along with you, right? So let's get that 8x out of the way. We're going to take that and we're going to subtract that to the other side. David, you got a question?
You can just subtract the 5y even if there's an x attached to the 3 still.
No, that's a good question. Not really. All you can really say is that this is 3x times y minus 5y on the left side. We got to leave it like that. And then on the other side, all we can really do is say this is negative 8x and then take away 1. All right, now we are so close. We're trying to get y by itself. We have y's on the same side of the equation. I count 1, 2 terms. And here's where the magic happens. We've got these two terms. They both have a y. We have to cook up a way of writing this so that there's only one y. I'm going to give you a hint. It starts with an F. Yes, factoring. Look at those two terms right there, folks. Factoring. What common factor did those two terms have? They both have a y. All right, everybody see that? So here's what we're going to do. We are going to factor out y. So your fourth step is going to be pull that y out, and we're left with 3x minus 5. And on the other side, we have negative 8x minus 1. Oh, we're there. We're there. This term right here, the 3x minus 5. You guys see that you can now divide that? So your last step, the fifth step, is going to be to say y is equal to negative 8x minus 1 is divided by the 3x minus 5. So a good answer would look like this. Let's see, this was k. So k inverse of x is equal to ba boop ba boop ba da 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 da. Whew. That would be mean of me. Now, I did last year. I don't know. We'll see how I feel about you guys. Okay, that is a good place for us to stop for today. Turn to your neighbor. Say nice work.
Nice work.
Okay. We're gonna get going on the quiz when the juniors come back. So you guys have some time here. You could relax. You could study a little bit for the quiz. If you have questions for the quiz, I'm happy to help you with them. Or third option, you could start on tonight's home fun. You'd probably get most of it done.